Hello everyone, today in this video we are going to solve some problems on acceleration due to gravity. So after this video you should be able to calculate acceleration due to gravity for different altitudes and different depths. So these are the difference formulae which we will be using to calculate the acceleration due to gravity. So acceleration due to gravity on the surface of the earth is constant. The value is 9.8 meter per second square. So anywhere in the surface the acceleration due to gravity is 9.8 meter per second square, and at some height from the surface of the earth the formula will be gh is equal to g bracket r by r plus h whole square. So this is the formula when the height is very large or comparable to the radius of the earth, and if this height is very small and if it is not comparable to the radius of the earth, that time we will use gh is equal to g 1 minus 2h by r, and the acceleration due to gravity at some depth from the surface of the earth will be given by gd is equal to g 1 minus d by r. So at this point the acceleration due to gravity will be given by this formula. So we'll be using these three formula to calculate acceleration due to gravity at different places. Now we will draw the graph between acceleration due to gravity and the distance from the surface from the center of the earth. So we will see graphically how g changes with distance. So first is inside the earth. So inside the surface of the earth the value of distance will be less than the radius of the earth. So r is less than the radius of the earth. So this is the formula, and I can find the LCM and write r minus d in the numerator. Now r minus d is the distance of the point from the center, so I can represent r minus d by small r. Small r is the distance of the point from the center. Now you can see gd is equal to g small r by capital R. So gd is directly proportional to the distance. So for directly proportional we have graph like this, straight line. So next, at the surface of the earth out here we know the acceleration due to gravity is constant and the value is 9.8 meter per second square, and it does not depend on the distance. So outside the surface of the earth, when small r the distance is greater than the radius of the earth, that means we are outside the surface of the earth. So this is the formula when h is comparable to the radius. Now r plus h is the distance, so I can represent it by small r. So I am representing it by small r square, and now you can see gh is inversely proportional to 1 by r square. So for inversely proportional we have graph like this. So now we'll combine these three graphs to show the variation of g. So this is the graph. So this side we are changing g, so I'm writing g dash out here, and this side is the distance, and out here is the distance which is equal to radius of the earth. So inside the earth g is proportional to r. So for proportional we can draw straight line. So this is for inside. Now when this r is equal to capital R, that time the value of g dash or acceleration due to gravity is 9.8 or g. So when the distance is r, we are getting acceleration due to gravity to be g. So outside is inversely proportional, so I draw the graph for inversely proportional. So by combining these 3 points we get the graph of g versus r. So now these are the important formulas. The percentage decrease in the weight of the body is given by change in weight by original weight, and change in weight is original weight minus new weight. So original weight is mg minus new weight is mgd divided by mg, that is the original weight, into 100. So this is the formula. So similarly for weight decrease due to height we can use this formula. Now we will solve some question on acceleration due to gravity. So we have to find the weight of the body at the center of the earth. So we know at some depth acceleration due to gravity is given by this expression, and when we take the object to the center of the earth, that time this depth will be equal to the radius. So I can write d is equal to r. So I'm putting d is equal to r out here. So this r get cancelled, we are left with 1. So 1 minus 1 is 0. So gd is 0. That means at the center of the earth acceleration due to gravity is 0. So when gd is 0, weight is also 0, because weight is m into gd. So there will be no weight of the body at the center of the earth. So now this is another question. How much below the surface of the earth does the acceleration due to gravity becomes 1% of its value at the surface of the earth? So one thing is given, gd is 1% of the acceleration due to gravity on the surface. So gd is 1% of g. So 1% means 1 by 100 into g. So it will be g by 100. So gd is g by 100. Now we know the formula. At some depth the acceleration due to gravity is given by this expression. So now instead of gd I can use g by 100. So this g and this g get cancelled. I'm left with 1 by 100 is equal to 1 minus d by r. Now I'm taking this d by r this side, it will become positive, and this 1 by 100 will come this side and become negative. So this is 1 minus 1 by 100. So if you solve this, you'll get 99 by 100. Now d is 99 by 100 into this r will come this side, so into r. So now if you put the value of a radius of the earth, you'll get d to be 6336. So that means at the depth of 6336 kilometer, the value of acceleration due to gravity decreased to 1% of its value on the surface of the earth. Now this is the second question. Find the percentage decrease in weight of a body when it is taken 16 kilometer below the surface of the earth. So these are the two things which are given. Radius is given and depth is given. So we know this is the formula. Now I'll put the values 16 and 6400. So when you solve this, you'll get 399 by 400 g. So now percentage decrease of weight is given by original weight minus change in weight by original weight into 100. So this is the formula. If you take m common, this m in the numerator and m in the denominator will get cancelled. So we are left with this. Now we'll put the values. So for gd I'm writing 399 by 400. Now you can see these two g are common. So I can take g out. I'm left with 1 minus 399 by 400. This g and this g will cancel each other. So I'm left with 400 minus 399 by 400 into 100. Two zeros and two zeros will get cancelled. So you're left with 1 by 4. And 1 by 4 is equal to 0.25%. So the percentage decrease in weight is 0.25%. So what is the relationship between height and depth for the same change in g? So when gh and gd are equal, we have to find the relationship between d and h. So this is the acceleration due to gravity above the surface of the earth, and this is for h less than r. And similarly acceleration due to gravity at some depth is given by this, and one thing is given, that is same change in g. So gh is equal to gd. Put the formula. So this g will get cancelled. So we are left with this is equal to this. So now when you solve, this one and this one also get cancelled. So you are left with 2h by r is equal to d by r. So this r get cancelled. So you are left with d is equal to 2h. So this is the relationship between height and depth for same change in g. So now you can try this question. At what height above the earth's surface the value of g is same as in mine 80 kilometer deep? So you'll use the same formula, gh is equal to gd. So using that you can find the height. And next question, at what height above the surface of the earth does the acceleration due to gravity fall to 1% of its value? Out here the acceleration due to gravity is decreased to 1%. That means it is becoming very less. So this happens when height is very large or height is comparable to the radius of the earth. So the given is gh is 1% of g, so I can write 1 by 100 of g. So now we'll use this formula. When h is comparable to r, we'll use this formula. So gh is equal to g r by r plus h whole square. Now I'll put the value of gh. This g and this g will get cancelled. So when you take this square this side, we will get root over 1 by 100 is equal to r by r plus h. Now root over 1 by 100 is 1 by 10 and r by r plus h. Now when you solve this, you will get h is equal to 9r. Now if you put the value of r, you will get 57,600 kilometers. So at 57,600 kilometers above the earth's surface, the value of g will reduce to 1%. So now you can try this question. So out here it is reduced by 36%. So I think you have to use h comparable to r formula, and out here you can see the acceleration due to gravity is becoming half. So for this also you have to use the formula in which h and r are comparable. Now find the percentage decrease in weight of the body if it is taken 36 kilometers above the surface of the earth. Now you can see h is 36 and radius is 6400 kilometers. Now this time they are not comparable, so I will use the another formula, that is gh is equal to g1 minus 2h by r. Now we'll put the values. So after putting the values, so 64 into 100 is 6400, so I can write g1 minus 1 by 100. So when you further solve this, you'll get gh is equal to 99 by 100 g. So now decrease of weight is change in weight by original weight into 100. So we can take m common and cancel the m from numerator and denominator, so we are left with this. Now we'll put the value. So instead of g, we'll keep z only. So instead of gh, I'll write 99 by 100 g. Now again you can see this 2g will come out and this will get cancelled with this g, and we are left with this numbers. Now when you solve this, you'll get 1%. So when you take the object 36 kilometers above the surface of the earth, the decrease in weight is 1%. So this is the end of the video. Please don't forget to like the video and subscribe the channel. Thank you.